Now we've learned about the linking step and the compilation step. So compilation comes first, it's compiled into object files, those are linked together into the executable. Now what happens when you run the executable? There's just one step left. You run the executable, right? So for example, if I go into the terminal, you'll see that I can once I'm able to compile it. So for example, I do this, and then when I do main.exe, something is happening, right? It executes this executable. Now what happens in that step? That's something to investigate. It's not as simple as it seems. This step is called loading, where the executable is loaded, right? Before we can discuss loading, we'll have to discuss a bit about the memory layout of an executable. Just briefly, you will encounter this in more detail in the theory aspect of the course when we study the memory layout of a MIPS program. But roughly, what happens is, in Linux or in Windows, in any operating system, the layout is actually defined by the operating system. But what happens is that the executable has a memory layout. Basically all executables have a memory layout. And what is this memory, right? So for example, you may encounter C functions or C programs which print the value of a pointer. What is that value? It's a memory address. And what's that memory? Where is that memory residing? It's in the RAM. This memory that we are talking about is in the RAM. These addresses correspond to RAM addresses. Not directly, but will not go into there right now. So they roughly correspond to RAM addresses. What happens is that typically the one portion of the RAM is preserved for storing the code, right? So this source code, the assembly which is compiled to, the source code and the assembly, which is not the source code directly, but the binary that is compiled to, has to be stored in the memory for it to be executed, right? It's not directly executed from your hard disk. It's first loaded into the memory, and that is called the text portion of the memory. Dot text, you may see in your assembly labs, right? Or the code section of the memory. Then there is a data section of your memory, where you know your read-only data or uninitialized data lies, or constants and static data lies, right? And then you have your stack. Now this is where all the memory allocations happen of your local variables, right? So whenever you maybe do int a is equals to 5, what happens is that the what the executable does is it allocates, not allocates, but directly assigns this memory address on the stack, on the top of the stack too, and gives and stores 5, the value 5 in this memory, right? And it goes downwards. So the next thing is going to be stored in here, then the next is going to be stored in here, and so on. So it goes downwards. And then there is the heap, and this grows upwards, right? Roughly. So things are stored in the heap. Basically whenever you do malloc, or the new operator of C++, or in C when you do malloc, things are stored in the heap then, right? And all of this is on the RAM. Now initially the layout of this is stored in the executable itself, right? So when the executable is created by your compiler, all of it is stored in the executable, that the code is going to lie from this memory address to this memory address, and these memory addresses are going to contain this amount of constant data or maybe static data, and so on, right? It specifies where which part of the memory lies, right? And it specifies the addresses where it's to be loaded, right? And when you do this simple step of starting the executable, this dot slash main.exe, it reads that memory layout from the executable. It reads all of that from the executable. What reads it? It's the loader which reads it, and this loader is actually part of the operating system. the operating system has this loader which will look at that layout, and it will actually load this all of this into memory onto RAM according to the layout, and then it will start the execution of the program from the code section of the memory or the text section of the memory. Basically it will tell the CPU, start processing and start executing instructions from this point, basically. And all of the references, they work. Now previously we had talked about the linking step. The linking step was precisely this: figuring out what memory address in the data section of the text section of the memory to call, right? So for example, when I do this foo, initially when we don't know where foo is defined, we don't know which section of the text section of memory to jump to execute this function. But as soon as G++ finds this void foo, it knows at which memory address this code is going to be located, and then it simply writes that this call is going to go to that memory address, and that is called linking, or it's called resolving references, basically. And that's what a linker does. And the loader basically loads all of this into memory and starts the execution of the program. Now, yeah, that's loading in a nutshell.